Okay, so the second part of this day is going to basically be on some definitions. The first definition we're going to get is something called an independent line, or an independent system. And what an independent system means is it only has one solution. It only has one answer. So an independent system might look like something like this, if this is my xy plane. Maybe this is one of my lines in green. This is one of my lines in orange. And it only has one answer, one solution, one intersection point. It doesn't have any more. So what I want to think about is when does a line have one intersection point? And the answer is the two lines will always intersect unless they are parallel. So the only time that they don't intersect is when they're parallel. So this lets me know that anytime I get lines that aren't parallel, they intersect. So what does it mean to be parallel? Well, it means that they have the same slope. So these things don't work, so they can't be parallel, which means they can't have a same slope. So like y equals 3x plus 4 and y equals negative 2x minus 1, well, this would be an independent system because their slopes are different. Now let's say I don't have an equation in y equals mx plus b form. Let's say I have something like, I have something like 2x plus 3y equals 5. And I have y equals 4/5 x plus 2. How could I tell if these two things are independent? Well, I can tell that this slope is 4/5, but I don't know what this slope is. Like, this is the question mark. So what I would do is I'd get this thing to become in standard form, or from standard form into slope-intercept form. So I would take the 2x over and get 3y is equal to negative 2x plus 5. Then I would divide by 3, and we could see that these things are, because the slope that I would get would be negative 2/3. That's kind of how you tell if something's independent. Let's check about dependent. Dependent means they have infinitely many solutions. So in this one, it doesn't mean that they intersect one time. It means that they intersect all the time. And as you can see, that would only happen if they intersect at every single point when it's the same line graphed over itself. So what you're looking for in these cases is you're really looking for a system that is this. These are dependent or have infinitely many solutions because they're exactly the same line. But most times you're not going to get it like this. Most times it's going to be like 3x plus 4y equals 10, and maybe you'll have 6x plus 8y equals 20. And if I was going to check, are these things dependent, I really need them to be in this form right here, so I can see if they're the same line. So again, you'd kind of go through the same steps. You'd say like this is 4y equals negative 3x plus 10. Divide this by 4. This would give you y equals negative 3 over 4x plus 2.5. So that's what this line is. I would now try to do the same thing with this line over here, which would give me 8y equals negative 6x plus 20. Divide this by 8, and I'd have y equals negative 6/8 x plus 2.5. And you might go, well, these are the same, but these don't seem to be the same. But if you reduce this fraction, you would see that this really is 3/4, and these things are, in fact, the same line. So again, dependent means that they have infinitely many solutions, or they're the exact same line. Last one. Inconsistent. Inconsistent happens when they have no solutions. Well, what would that mean? We saw this one on the last quiz. We saw lines that went like this. These lines are parallel. If they're parallel, they can't intersect. If they're parallel, they have the same slope. So we are looking for these things. Same slope. These check out. Again, they're going to give you things like 3x plus 5y equals 10, and they'll give you probably something like y equals negative 3/5 x plus 4. And they'll want to know, are these things parallel? And again, you're going to take the exact same steps. Convert this thing to y-intercept form, which when you subtract everything over, you'd get negative 3x plus 10. Divide these things by 5. And as soon as I divide it by 5, I can go, oh, this slope and this slope are the same, so they are in fact both parallel. So again, for these three things, you need to convert everything to slope-intercept form, and after you convert them to slope-intercept form, you can check whether it's inconsistent, meaning you have no solutions, it's dependent, meaning you have infinitely many solutions, or it's the same line, or last, it's independent,